This is how we taught it in first and second grade. They are called fact families. This is how you learn it. So if you're like, are you kidding? You want me to do this? I do. I do. Because we don't learn 1 plus 3 is 5 by itself. We learn that 1 plus 3, sorry, that was 1 plus 3 is 4.
13 minus 8.
4 plus 3 is 4. We also learned that 3 plus 1 is 4. And we learned that 4 take away 1 is 3. And we learned that 4 take away 3 is 1. Okay, you got some fact families for me. Did you do this? Did you do 13? Take away 8 equals 5. Or you could have even done 13, take away 5 is 8. And let's take a look at this guy on the bottom. I could say 7 plus 9 equals 16. Now the reason I'm showing you this is this. First thing is, we learned, okay, everyone's watching me. What we learned back in the day is when we teach elementary school, we learn operations. We don't say this to little kids like, oh, we're learning inverse operations, but we learn them together because they really do work together. Adding undoes subtracting, and subtracting undoes adding. And we learn them that way when we teach little kids. And today, we're going to do logarithms. And every freaking year I teach this, some kid will say to me, but Miss T, what is a logarithm? And that's like asking me, Miss T, what is a multiplication? And it's like, multiplication is not a thing, it's an action, it's a verb. We multiply, we subtract, we take the log. It's an action. Here's why we don't like it. We don't like it, number one, because it's weird, and number two, it does not have a nice symbol. When we multiply or add, we get this really cool little symbol. When we multiply, we got this, and when we divide, we got this. We got even a square root, we get this guy. And we get all sorts of nice symbols, even exponents. Even exponents, 4 to the third, it's got the little subscript. Do you know what log gets? He gets nothing. He gets this word. It's so stupid, but it messes you all up because it's like, well, that's a word. What is that? It's like, it's not. It's an action. I believe I should invent a new symbol. This should be the symbol for logs. You know why? Because it's pretty and it's fun to do, right? Like it should be twirly. It should be a twirly thing. I've invented that. There you go. You know what? I just invented math. But honest to God, that's why it gets in your head. It's like, but what is a log? A log is an action. So let's think about what that is. Are you ready? So here's what. This right here, let me find him, this dude right here. So here's the good question. This is what we're used to. This is called exponential. We're finding what happens when we raise things to a power, right? We're finding the answer if we do a power. What logs do is they do the undoing. They say, what if I know the starting place? And what if I know the answer? What power would work? That's all we're doing with a log. You just took the log of this. If I said this, 5 to the what equals 25, and you went, that's squared, or that's 2, you just logged it. This is not the right word. You just took the log of it. You just didn't even realize it, right? Eventually, in real life, if I said 137.615 divided by 5, you'd be like, I don't want to do that. You'd use your calculator, right? You know how to do it, though. You use your calculator. Same thing when we do logs. When I give you 3 to the I don't know equals 702.6, you don't know what that is. But you know what? Your calculator does, because it knows how to undo exponents. That's what logs are. So here we go. We're going to write some stuff down. Are you ready? And it's important to write this down because we don't. when you're a little kid, and you learn this, you do 20 divided by 5, and then your teacher says this, put in this form. Little kids have a real hard time with that. They're like, which one goes in the box and which one goes outside? Like, it's like, oh my God. Same thing with logs. Because we don't use them that much, you guys have a hard time remembering how to write them. So let's start with, what is a logarithm? It is an action. Write this down, an action that undoes exponents. It's the inverse of exponents. So if we can take something to a power, we can undo that by logging it, taking the logarithm, right? Here comes the important part though. So here we go, write this down underneath. If we have, let me think of a good one. 2 to the third equals 8, right? 2 to the third equals 8. Let's talk about some vocab here. We think of this as our base number, right? That's our base, and that's our exponent. We're raising it to a power, and then sometimes we call that the answer, right? Like, that's my answer. But in pre-calculus, we're going to call it something fancy, and it's called the argument. So I'm just going to let you know that that's actually its word. Okay, so here comes the letter version. A to the x equals b. A is our base. X guy is our exponent. See what I did there? And b is our argument, or our answer. And now we have to remember, how can we unwrap this guy? Because what we're going to be doing in this whole chapter is we are going to be solving for this guy up here. Almost all of our problems will have that x trapped in the attic. And we're going to need to figure out a way to get him down. And here's how we do it. So what we're going to write, and see if you remember this from last year. Log. Would it be nice if it was that squiggle thing? Yes, but too bad. It's not. So in my head, all day, I have said the same words in my head. I'm not lying. I say this. The base goes in the basement. The exponent is the answer. So watch what I'm going to do. The base goes in the basement. The exponent becomes the answer. And the b goes here. Honest to God, if you get nothing else out of today, it's remembering the base goes in the basement. The answer now is the exponent. So let's rewrite this guy in logarithmic form. Are you ready? Log or squiggle. No, you can't really do that, but I want to. Okay, log. The base goes in the basement. The exponent is now our answer, because that's what we're solving for, right? And the argument goes right there. He's called the argument. Because what this is saying is 2 to the what will give me 8. Oh, that's 3. That's how you take a log. You say 2 to the what power will give me 8. That's logging. That is taking the log, right? So the first thing I want you guys to do, pick out 2 of these. I don't care what 2 you do. I would like you to practice, please, writing any of these 4. Do 2 out of the 4 in logarithmic form. Do it on your arm, do it on your leg, do it on your desk. I don't care. But I swear to God, you're going to say that. The base goes in the basement. The exponent is the answer. And it's not that it's hard, but it's like that little kids when you have to know which one goes in the box and which one goes out of the box. Log. The base goes in the basement. The exponent is the answer. 64 goes here. Because what we're saying is 8 to the what will give me 64. I will write them out real quick. The base goes in the basement. The exponent is the answer. The argument goes here. You got to get good at them, though. Honest to goodness. The base goes in the basement. The exponent is the answer. The 49 becomes the argument. The base goes in. Oh, look at this. We can even do square roots now, because that's the square root. So we're going to say the base goes in the basement. The exponent is the answer. There we go. How about the other way? Can we go the other way? Pick out, let's see, what I want you to do. Pick out any two of these. Rewrite them in exponential form. Take the base out of the basement. The exponent is the answer. And they should work, right? They should make sense. But you have to be, it's been a year. We haven't done these in a year. No one does these in their spare time. Ever in life, like literally. You use them in calculus. You use it, oh, actually, that's not true. This is one of the few times in life where real life problems use logs. With COVID, it was my big moment because COVID was exponential growth. People would, in grocery stores, I would hear them say, I don't believe it's true. You can't go from 10 cases to 1,000. And I thought, yes, you can. That's how germs work, you dumb. No, sorry. I did get angry with people. I didn't. I stopped. 3 to the third equals 27. 81 to the, look at this, square root equals 9. That's a square root. That's 1/2. Look at me. 14 to the squared equals 996. And the last one, 12 to the 1 equals 12. Nice and easy. Okay, so let's use it. Let's use it. Here we go. Oh, we already did this once. Here we go. Can you, with your neighbors, solve these 4 problems? All we're doing is we're rewriting them. Now, I'll be honest. You have 2 ways of doing this. Some of you, and I'm going to point at my friend John. My friend John knows how to do this in his head, right? He is literally going to say to himself, 4 to the what gives me 16. John, 4 to the what gives you 16. Dude, he doesn't have to do anything because he actually is just doing the log in his head. But if you're not comfortable with this, if you're like, Miss T, I don't always get these, then rewrite it. 4 to the what gives you 16. And if you even want to go one more step and say, oh, wait a second, that's 4 squared from last night. Nice and easy, right? So can you, if you're pretty solid at what logs mean, do it in your head? I'm fine with that. But if you're not comfortable, go ahead and rewrite it. Rewrite it in a form that we like. You know how I always do that double change thing? That's because I write it into a form that I like. X is 2 here. 3 to the what is 27. X is 3 here. 7 squared is 49. X is 49 here. And the last one, what squared is 25? Because that's what I'm asking. And the answer on that one is 5. How'd you do? Just about knowing how to rewrite things. Can we make them a little bit tougher? We can. We can. Not a lot tougher. So that looks scary. I can't do that in my head. But you know what? If I rewrite it into a form that I like, it's very basic algebra 1. So all I'd like you to do these 2 problems for me, please. I'm going to walk around, rewrite them in exponential form. Rewrite them in exponential form. You are rewriting this as an exponent in exponential form. 3 to the 1 equals what? And then you're going to be like, oh my God, you see, these are so easy. It looks scary though. Beautiful. Go ahead.
I didn't do it.
He did that. 3 to the first equals x minus 5. 3 equals. How'd I do? Am I good? X equals 8. How about the next one? 2x minus 4 equals, look at that, 36. X equals 20. I move the 4 over, divide by 2. Am I good? Easy? Okay, last thing, best thing. There are some weird ones. I'm going to show you how the weird ones work, and I want you to write these weird ones down, and I'm going to show you a shortcut. Are you ready? This one I actually do need you to write down. Teachers probably tried to teach this to you last year and you didn't get it. You all had done. So I'm going to tell you that she showed this to you and you're going to be like, I don't really get this. Yeah. Yes, absolutely. So here's what I do. I don't like that form, Kathy. I really don't. So I'm going to say the base comes out of the basement. The exponent is the answer. Are you cool with that? Equals the argument. Just rewrite it in a form I'm comfortable. 6 squared is 36. And then, yay, I'm happy. Honest to God, once I'm in a form, again, it's like that, doing that double change. That makes me happier than trying to minus a minus, right? Okay, here's the first weird one I want you to write down. Write that down on your paper. Everyone's writing this one down. You're actually writing this one down. You're writing this one down. Write this one down. Write this down. This looks terrifying. Zach's writing this one down. I got 2 that I need you to write down. This looks like a terrifying problem. You're like, what the holy hell? And I'm going to tell you it's the easiest problem that you could ever do. And then I'm going to show you a shortcut so you don't have to do it.
57.
It does. X does equal 57. So here's what I want you to do. I would like you with your neighbors to rewrite this in exponential form. Are you ready? The base comes out of the basement. The exponent is the equals. And this stuff is my answer. And look what happens. A terrifying problem becomes easy because what you can do when you, I think you're already saying this, that when you have a base and an argument that are the same, you can't really cancel them. You can ignore them. Yeah, you can ignore them. So watch how nice that is. Oh, let's do this one with no math. No math. Is my base and my argument the same? Yeah. So can I, in essence, ignore them? Yeah, you get a nice 15. Okay, I want everyone here though. Sorry, you got it? I got it. You got it? I want everyone to do this one right now. No one doesn't do this one. Everyone's doing this one. Gentlemen and ladies, everyone's doing this one. Use the trick. Do this one. You guys ready? Do that one right there. Do this phone. Do that.
I want to try that. Equals what? Equals 10.
Do the second one. Use the trick, and then just do basic 8th grade math. Do this one, yeah? Okay, nice easy answer. Negative 5? Yep. See, but they made it really look scary and hard, and it's not scary and hard. Okay, I think we got one more that I want to do.
Yeah, so you get minus 10 equals 3 equals 5.
Okay, so on this one, I am going to pick up my pace a little bit, and I'm just going to give you the shortcut right away. It works the same way if you raise something to itself. In other words, look at this. I got a base and a log of itself. They both have 3's. You get to cancel them the same way. I can show you why that happens. I'm going to do it real quick. Here's why. You're never going to have to do this. I'm going to say the log of 3, and I am going to write this in logarithmic form. The base goes in the basement. The exponent is the answer. Don't worry about this. You're just watching me. The reason I wrote this, look what happens. This cancels with this. You just get x equals 9. Here's the takeaway. If the base and the log guy are the same, if I'm raising it to itself, they cancel out. Okay, I have one other thing to say, and I love this last one. That's not it. I'm finding it on your test. Oh, I love this problem. So love this problem. love this problem. Let me get rid of this. Could you please try this problem? Just rewrite it in logarithmic form and think about what we did last night. Yes.
I don't know how to do this one.
Oh, yes, so make it 8 squared.
He's been at hurt a while,
8
right?
squared.
X to the
And then
next.
move it up to the top.
8 to the next.
Oh, this one is
Next. That's to the next.
negative.
I don't want it.
That's one.
I don't like it.
Like,
That's equals
Did you get negative 2?
Yeah.
We're done. We're done, lambs. That's it. You are going to do one column or the other, and the problem's on the back. It will take you 10 minutes. You're welcome. Have a good weekend. I'm going to give you your test back. Where's that? Oh, I would like to check off last night. I need at least 2 on the back to get full credit. I did say 3, but I made the other kids only do 2. So if you do 3, I love you. Bye, everybody.